Okay. My calendar. You are implementing a program to use as your calendar. We can add a new event if adding the event will not cause a double booking. A double booking happens when two events happen in a non-empty intersection. Some moment is common. Wait, what? Two events have some non-empty intersection. Some moment is a common to both. That makes no sense. The event can be represented as pairs of integers start end that represents a booking on the half open interval. Is this an interval problem? Oh no. The range of real numbers x such that start is less than or equal to x and is less than to end. Implement my class, okay. So my calendar, it creates the calendar. We book from 10 to 20. Return true. We book from 15. This should be false. Okay. Book from 20 to 30. True. So it's 20 exclusive. Okay, this is an interval problem. Okay. This should be cake. Low key. Low key. This will be cake. I say that now. I'm gonna screw it up. Okay. How do we want to store this? How do we want to store this? How do we want to store this? Can we just store it as an interval? Yeah, why don't we just store it as an interval? At most 1,000 calls will be made to book. That's not helpful. Constraints start and 10 to the 9 int start. So we can store them in ints. Okay, so I'm thinking intervals. Class interval public start. I know public end. I shouldn't do that. I like this better than doing the size 2 array. Okay. 1,000 calls. Why would they tell us that? I'm sure that book might take O of n. Yeah. So so what we can do is like interval curly interval equals start get 0. What happens if we call that? What happens if we call that and it's empty though? Equals size is greater than 0. 0. Otherwise it's null. Sure. 1 minus or wait, isn't this just merge interval? Okay. I think I'm thinking about this wrong. We don't even need this. No, not start. Interval index, right? Start end. Oh, this is bad. I actually have no clue what I'm doing right now. Like, I don't think I need to be I think I'm trying to do too much. So we've moved to the point where the start... I think this needs to be end. Where the end is always less than this, so... Sure, why not? Oops. Because this will just break execution. It'll suspend execution at these two lines. So what happens is we enter 1020. Interval index is 0. So we add the interval, and then here we look at 20. We say, is 20 less than 20? No. So then cur start, cur end. And then is cur start less than 20? It is. I'm doing this wrong. Well, a start greater than cur start? Yeah, okay, I'm doing this absolutely wrong. Yeah. So how do I check if it's inclusive into any? So the two things we need to do. We need to check the start, and then we need to check the end as well. And we need to make sure that it's not in any of the values. So if cur start is less than start and start is less than cur end, then we return false. And then we do the same here. So end and start is less than cur end, then we return false. And I think we should be good here. Yeah, let's see. There's probably some edge case. No way! Okay, we're doing something really wrong though. Yeah, we're doing something really wrong. Okay, how do we optimize? Yeah, it's tricky. I'm thinking like maybe binary search. Oh, this assumes it's... Oh, shoot. This assumes it's sorted, doesn't it? Or at least from... I'm not gonna lie, I don't know how this passes. Yeah. Unless the start will always be after. This is then. I mean, the only other way we can make it faster is end log n. Yeah, I don't like what this axis. Both this axis is of 1. It's really the traversal that is the only thing we can optimize. Yeah. So maybe don't use a list, or if we do, we have to binary search it. Binary search. There's no way to iterate a priority queue though. A priority queue would help, I think, but there's no way to iterate it without polling. Can we? Because then I would like couple it with the hash map, and that would make that would allow us to like binary search it. But there's no way. Maybe we should go under the assumption that that doesn't really help though. The reason why binary search won't work is because we're doing ranges. Yeah, how do we make this faster? Maybe it's the data structure we use. And set, we wouldn't be able to iterate. Hash map would be more storage, and we wouldn't be able to iterate. Queue, we wouldn't be able to iterate without like polling. Stack, this doesn't really make sense as a stack problem in my view. Like, this is no different than having a two-pointer solution. Like, we could do a two-pointer, but it's really that much faster. It's still O of that. Yeah. Let's see. Oh my gosh. Oh my gosh. I don't even know how tree map works, to be honest, but that's unfortunate. Wait, what did this guy do? Okay. Okay. Oh, he used a linked list? Wait, that's actually really smart. Oh, wow. Using a linked list is actually crazy smart. That's smart. I just, okay. I gotta look up how tree map works. It's a red black tree. Okay, wait. I really don't think mine is that suboptimal. I don't think it's optimal, but this is so much smarter. Wait. So how does the tree map work? It sorts. Smallest key, largest key, floor key. Get the largest interval whose start time is less than or equal to start. Okay. Get the smallest interval whose start time is greater than start. I don't get it. I don't really get how floor entry works. Method gets the interval with the... What's the comparator? There's no comparator. And compares the ends. Oh. So you make a tree map where all the starts are the keys and all the ends are the values. And then you and then when you try to add, you say, okay, get the nearest start value that's lower than it. Get the largest interval whose start time is less than. Yeah. You get the nearest floor entry. Yeah, so you get the nearest start that's lower than it. Then you get the nearest start that's above it. And then if you get the value and it's okay. This is making a little more sense. So if we go here, okay, I see now. So it's what's the Be right back. That was useless. Okay, are we... Okay, we're good. Ceiling entry. Wait, what? Isn't that what I did? Why is the start the only thing that matters? Like, why don't we need to check for ends? Oh, because okay, I think we don't need to check for ends because we're only checking for the front overlapping, and when we're adding from front to the beginning. Do we not need to worry about the end value because we are adding in order only, and as we add, we know nothing will be after it. Oh my gosh. See, why don't they tell me? They don't say that, like, they don't say it's added in order. Or like, yeah, like. So is it a given assumption that the intervals are added from greatest to greatest in start by starting time? Bruh! Why? That's so useless. Like, it wastes so much time. Like, how hard is it to add something right there? All intervals are added in order by start. Huh? Like, bruh. So frustrating. That changes, that because that would have changed how I approached the problem. I could have. No, I definitely couldn't use a priority queue. But yeah, it's like, that's frustrating. Okay, so they change. I think I have it the opposite way, like this. There we go. Yeah, so it just changes book to log n or log n. Yeah. Okay. I like this problem too. I've liked all of the daily challenge problems I've done so far. So, yeah, and I'm getting them all too. Like this is the first time I think I didn't get the optimal answer, but I'm not too upset about not understanding a tree map. So yeah. But I'm putting him here because I really like those problems. Cool. Okay. Yeah, so we're getting there, but we're adding more hards and mediums for sure, which is good. Just gotta keep on going and keep on grinding that out. Wow. Pretty happy with that. Pretty happy with that.